What's up, notJust developers? Today we will learn how to build a beautiful parallax effect in React Native based on the phone sensors. For that we're gonna use the React Native Reanimated library, and that will allow us to get the information from the phone sensors, such as the gyroscope, and to use this data to drive our animations. Stay tuned till the end of the video to see a more advanced use case where we implement a 3D parallax effect with multi-layer images. If you want to follow along, make sure to download the guide and the starter project that I have prepared for you, following the link in the description below. And without wasting any more time, let's jump into it. Let's go ahead and we're gonna start here in a blank project. We're gonna start by rendering an image. So let's import the image from React Native, and also in the assets I prepare for you a couple of images that you can download in the description below, of course. Let me grab them. For example, I'm gonna replace all my images folder with the one downloaded from below, replace, and here in the images I have, for example, a BG, the background picture, and some other picture that we will use throughout the tutorial. So let's import this background picture from assets, images, and the background.jpg. Now, having this image, let's go ahead and remove the text and render the image with the source background and style. We're gonna style it as image, or let's even do image. Alright, now at the moment the image is very huge, but if we're gonna say that we want this image to have a width of 100% and a height of 100%, this will make sure that our image is displayed on the full screen here. Alright, so what we want to do next is going to be to get the input and the data from the sensors, and then we're gonna see how to drive the animations for this image based on those inputs. For that we're gonna use React Native Reanimated, so we can go ahead and install React Native Reanimated in our project, and actually there is Expo React Native Reanimated documentation that explains how to install React Native Reanimated in an Expo project. So if you have an Expo project, then let's go ahead here and copy this command npx expo install React Native Reanimated, paste it in the terminal of your application. I already have done that, and if I check my package.json, I see that I have React Native Reanimated 2.9.1, and the next step to make sure that it's working is to add these plugins, React Native Reanimated /plugin, in our babel.config. So if I'm gonna go babel.config here, you see in the plugins I have a plugin attached. After that, restart your server and run the application again on the device, and everything should be working fine. Now from Reanimated, let's import the whole library animated, and also let's extract some of the things that we will need there. One of the things that we're gonna use for today's tutorial, if I'm gonna go here in the API references, we're gonna see hooks, and there is a hook use sensor, use animated sensor. So this use animated sensor, based on this, you can easily create cool interactive animation based on the data from the sensor in the device, such as the gyroscope, accelerometer, and so on. So let's go ahead and see how we can use it. Well, first of all, let's import it, use animated sensor, and let's declare it here. So const sensor equal use animated sensor, and inside it we need to provide which sensor we are interested in. There are a couple of sensors, and all of them are stored here in the sensor type, and we can provide here the sensor. There is the accelerometer sensor, there is the gravity one, gyroscope, magnetic field, but what we're interested in is in the rotation of a device. The rotation at one specific point in time of a device, and based on the rotation, how the device is in your hand, we're gonna drive these animations. Okay, so now what we have to do, we have to define an animated style for our image that is going to be calculated every time our sensor updates. Basically every time our sensor has some new value. To define an animated style for our image, we will import use animated style, and let's go ahead and say const image style equal use animated style. And here we're going to provide a function that will calculate and return the styles that we want to set for our image. But for now, what I want to do is basically I'm going to console log our sensor.value, or yeah, .value, for example. All right, I'm going to do that here. And if I'm going to open our terminal, undefined is not an object, parent ID length. Let's see. I'm gonna restart our server and let's start it again. Let's reload. Use animated style has to return the style object. So let's return initially an empty object for the style, because in a moment we're gonna think how we can animate the style for this image. All right, so as we can see, we see two log boxes here. And for every event, for basically every time we're console logging, we get an object with a lot of value. These values are the pitch, the QV, QX, QY, QZ, roll, and I don't know how to pronounce this one. Basically, yaw? No idea. So basically we have 4 values. These are the full 4 values that represent the rotation of a device in the quaternion way. Don't ask me what's that, because it's too complicated for my brain to comprehend. Even though like 4 or 5 years ago I was developing games, and back in that time I knew exactly how to work with these quaternions, and I knew what are they, but now I try to understand them and my head just exploded. The other 3 values, pitch, roll, and yaw, these are much easier to understand. It's very obvious to understand roll, pitch, and yaw based on an airplane. So the axis yaw basically goes straight to the middle of the center of the Earth. When we rotate around this axis, we're basically rotating in what direction we're facing, basically north, east, south, and so on. So rotations on this axis go from 0 to 360, and more details you can find in the documentation which one is which. So this is the first axis. The second axis is the, for example, the roll, and this specifies the roll of the airplane, like how it rolls. And lastly, the pitch specifies if the plane is going upwards or downwards. So that's basically the same with your phone. We have these 3 axes, and the rotation of a phone is represented by them. I'm gonna go ahead and connect my phone to the computer so that we can all see how these values change, and we're gonna see how we can work with them. Here you can see screen sharing directly from my physical device. So we're gonna be able to, for example, launch the application, and we already see a lot of numbers here. So one way we can do to decrease a bit the rate at what we receive as console logs is for the animated sensor to provide here some configs. And the config is the interval. How often should the sensor update? If we don't specify anything, it will automatically update as much as possible based on the device refresh rate. In our case, let's do, I don't know, like 4 times a second, which is every 250 milliseconds. And if I'm going to reload, it's still quite a lot. If I do 500, it's much better. If I do 1 second, we see them at every second. All right, so in order to see and to visualize and to understand these values, let's go ahead and destructure them from our sensor.value, and we're gonna destructure all of them. So starting with the values that we are interested in, and these are your pitch and roll, and then we're gonna also actually, let's not look at the quaternion notation. Let's only focus on these 3 values. And now I want to render them like this. Then I want to render the pitch and the roll as well. But we don't need that many digits to understand what is happening. So I'm gonna do dot to fixed. 1 digit after the dot will be enough for us to understand what's changing when we move a phone. All right, here we have it. Let's have a look. Is it still console logging? Probably. All right, now it's better. So what we see, remember the first value is yaw, pitch and roll. Now we update every second. My phone is flat on the, okay, let me, how to do it properly, so that you can see it as well. And let's have a play a bit around with the phone, and then we're gonna see. Having the phone with the screen upwards, I'm gonna rotate it basically around the axis that goes up. So I'm gonna rotate it like this, and as we can see, the first value here decreases until it reaches 0, and then it increases until it is back to 1.6 or something like, no, not even 1 point, it's even more. I think it should be up to 3.11, which is exactly P, because these values are in radians. So now we understand the first value, which is our, let's have a look, what is our first console log value. Our yaw is the direction of basically towards north, east, and so on. Now let's start moving the phone upwards, basically the way you would look at it. So starting from here, if I'm gonna start moving it upwards, we see that the value in the middle goes to 1.6 when the phone is fully vertical like this. And if I continue rotating it, it goes to 0.20 and back to minus 1.6 when it faces down. So we see that the second value is basically the rotation of the phone, the pitch around the axis that is horizontal. So axis horizontal, so we are moving around this horizontal axis. Now lastly is the roll, and the roll is basically, if I'm gonna have a phone like this, the roll is the last value, and it indicates how the phone is rolling on the left or on the right. So from these values, what we can understand is that we can use them to drive some animations for our image. But what specifically are we planning to move around? Well, basically, whenever we tilt the phone forward and we're looking from the bottom of the phone, we want to move the picture, the background picture, we want to move it a bit upwards. And when we do the opposite, we want to move it a bit downwards, and so with the other axis as well. Basically, when the roll changes, we want to move the picture either to the left or to the right, because that's how you roll the phone in your hand. So what are we going to need? I think I'm gonna also draw something for you in order for us to better understand how we are moving this picture. It's gonna be easier for me to explain some of the numbers that we have in a moment. Okay, so our device screen is this green thing. That doesn't look like a device screen, so I'm gonna do it again. This is the device screen. Okay, now our picture at the moment, the way we are displaying it is basically 100% width and 100% height. So basically it has the same width and height as our frame here. But in this case, we are not able to move this picture up and down, because basically whenever we will move a picture up or down, we're gonna leave some empty space because it's not enough size. So what we have to do is actually render the image a bit bigger than our screen in order to have room for movement. So something like this. This is our image, and by having this we will be able to move the image up and down based on the device. In one case we can have an image like this, and we're not gonna see any empty white places. In our case, we can have an image move like this, and we're not gonna see any white, and so on. And also on to the left and to the right. So let's go ahead and first add this padding to the image in order to have room to work with. So we're gonna define how much do we want to offset this image? So let's define this in a variable at the top. So const image offset is going to be equal to, I don't know, 50 pixels or 100 pixels. We're going to see, and we're going to be able to adjust it as we want and as we see fit. Now, based on this image offset, I'm going to go ahead and in the styles of our image, we're going to provide here the width and the height. For that, we actually need the width and the height of our screen. So let's go ahead and import from React Native, use window dimension hook. And in our application, before we get the sensor, let's go ahead and get the width and height of our window dimension. This will give basically the width and height of our screen. Now, based on this width and height, we can give some styles to this image. So instead of providing the styles from there, I'm going to provide them right away here. So width is equal to width, height is equal to height. Now we don't need the styles here anymore. And as we can see, just by providing it like this, our image is displayed as it was before. But if we're gonna we want to increase the width of this image with the offset that we're gonna need for our animations. So if I'm gonna say image offset, and here as well, we're gonna see that our image is actually a bit more zoomed in. And we're gonna see that if I increase this to 300 pixels, right away you can see. Another thing that I want to do is to add to our width double the amount of offset, because we have offset to the left and offset to the right, and the same thing for our height. We have offset to the top and offset to the bottom. So by adding them like this, we see that our image is actually zoomed in, and now we have space to move this image around on the screen in order to give this parallax effect. I was working with, position absolute. Let's try position absolute, and by playing with the top position, for example, if I'm gonna set top position 0, we see that the image is moved a bit to the bottom. If I'm gonna say top position 100, that's even more, but top position minus 100, that's gonna move to the top, minus 200, again more to the top. And these are the properties that we're gonna use to drive the animation. Top and also left, for example, minus 200, that's going to be like this, 0, that should be like this. So if this will be our animated properties, we're going to move them from here to our animated style for our image. So let's go ahead and provide them from here. We're going to put them in our animated style. And the next step is to actually send this image style, which is our animated style, to our image component here. For that, we're gonna have to replace the normal image with an animated.image, because that's what we have to do in order to give some animated styles. And secondly, we're gonna provide the animated style in this array as the second property. So image style like this. And now, besides the static styles that we have here declared, we also apply these styles that are at the moment also static, but we're gonna implement them based on the pitch and the roll. Okay, so as we said, the position, moving the image to the top and to the bottom, will be driven by the pitch. So if I'm gonna do, for example, I don't know, let's say pitch. Actually, I see something changes, but if I'm gonna multiply this by, I don't know, minus 50 or actually 50, just to play around and see what's going on here. It's not very smooth because we have this interval 1 second, and let's remove it because we are not debugging anymore. We want to see the smooth animation. And now if I'm gonna move my phone like up and down like this, we see the image is moving somehow. Now it's like this. Okay. And let's do the same thing for the left. So the left, our roll will drive it. So let's do also 50. And here, as we can see already, if I move the screen around, the image is moving as well. Well, it's not properly moving, because we are just testing it out right now. And in a moment, we're gonna think about how we can derive this top value based on the pitch and based on the roll. For that, let's first focus on that top position. The pitch value goes from negative we can have a look at the console logs so we can see what we're talking about. So we have console log pitch is in the middle. So let's have a look at the values for our pitch. What is the range of the values? Basically, what is the minimum value and what is the maximum value? So if I'm gonna hold it like this, that's 1.5. If I'm gonna hold it like this, that's basically 0. If I'm gonna go there, that's minus 1.5 somewhere there, or actually 6, yeah. So as we can see, the values go from minus 1.6 to plus 1.6. And this 1.6 is not a random value. This is half of P. Basically, it's the angle in radians. So 1.6 is P over 2. So what we need to do is to somehow get the top value based on the pitch, knowing the range of the values that the pitch has. So for that, we're going to use an interpolate function. So we're going to interpolate based on the pitch. First, we need the input range. And as I said, the input range of the pitch goes from minus P over 2 till P over 2. So I can have it here actually, const P. I'm gonna take it from the math.p. Let's do half equal P over 2. And yeah, this way it's gonna be easier for us to understand here. So as I said, our pitch goes from minus half P and it goes to all the way to half pi. Okay, these are the input values. Our output values will be in what range should our top value move? Basically from what value minimum to what value maximum. If we're gonna play around like directly here with the top position, so if top is 0, everything is okay. If top is negative, I don't know, 100, the picture moves to the top. If it's negative minus 200, the offset is too much. The offset, yeah, let's put the offset 100, so it's gonna be easier for us to understand. Offset is 100. So if we move 200 pixels, that's gonna be maximum how much the picture can move up, because if I add 20 more pixels, then we're gonna see the white at the bottom. So that means that top goes from minus 200, which is 2 times more than our image offset. All right, let's put it here. Image offset multiply by 2, and that's minus. So from minus that till, let's also manually have a look at the maximum top value that we can give. Probably that's going to be 200. No, 200 is too much. Actually, it's going to be 0, because when it's 0, it's all the way to the top. If it's already 10, that's already moved to the bottom. So maximum value will be 0. All right, so that means that the maximum value is 0 here. And now, however I'm gonna move my phone in the hand, the image will always be visible, because we properly matched the pitch input range to our image offset, basically the image top position offset. So now if I hold the phone like this, or I'm gonna do it for you, and if I move it a bit to below, you can see how the image basically moves to the top, and it gives you the feeling that you're looking from the below of the image. I can increase this simply by increasing the image offset here to 200, and this is gonna be like way more movement. So like this. Hopefully you can see it. Let's do the same for our left position. Our left position is going to be an interpolation based on the roll. The input range for the roll is actually not half pi, but a full pi. So pi, I mean from minus pi to simply pi, and the ranges that we want to do is gonna actually be the same as here. Now, if I'm gonna roll the phone there, the image moves in the same direction. If I'm gonna roll the phone here, the image also moves. So now we have this beautiful parallax effect, and the way we are moving, the picture moves here on the screen. Another thing that we can do is to smooth up a bit the animations, because at the moment our values are directly dependent on the sensor values like pitch and roll, and we sometimes can make the animation look not as smooth. If, for example, the sensor values glitches, or I don't know, it changes too fast. For example, there is one moment when our axis change, so in that situation, like, it doesn't look very beautiful. What we can do is to put a timing animation on top of this value, and that will make sure that we slowly move in the desired direction, not directly. So for that we have a with timing value. So let's go ahead and wrap our interpolation in with timing. And what this will do is it will move the top position towards the desired position, this one, but it will move in an interval of time, basically slowly over time, frame by frame. And by default, the time is 300 milliseconds, but for us, that's too much. So we can adjust it here in the configurations, and we're gonna use a duration of only 100 milliseconds. And let's do the same for the second interpolation with timing, and the configuration here, duration is 100, just like that. And now, if I'm gonna reload my application, yeah, now our animations, as you can see, are a bit more smoother. And if we like move the phone a lot around, like, the animation will not jump from place to place as it used to be. Now it slowly goes in the desired direction. For demonstration purposes, 200 is good, but I think for actually, like, in the hand, it feels much better when this effect is not that, like, obvious. It's very small, and 100 or even 50 can work well. All right, so what is the next step? The next step, let's actually create a component out of this and move it into its separate component, because that's going to help us for the next step, and the next step is even better than this one. So what I want to do is, in the source components, let's go ahead and create a new file for our new component, and let's call it sensor animated image.js, sensor animated image. Let's copy everything from the application, because it's going to be easier for us just to remove what we don't need. For example, we don't need the status bar, we don't need probably this view, and also we don't need this container, we don't need these styles. And let's see what don't we need from here. For example, status bar and a lot of components here. Now it's much better. Let's rename this from application to sensor animated image, and let's export it like this. Now in our app.js, instead of rendering this image, let's simply render the sensor animated image like this. In the sensor animated image, instead of rendering the image that we import here, let's go ahead and actually receive this image in properties, because it's going to make this component much more flexible, so we can send any images and it will animate the way we want it. So let's do image here. We're gonna receive it for properties as image, and let's render it here in the source as image. So for that reason, we don't need the background import here anymore. But from app.js, what we have to do is to send here to the sensor animated image, the image which is background. Yeah, like this. And now let's go ahead, and from app.js, we don't need any more the animated style, the sensor, the height, the width. Basically, our application is back to a very small and clean component like this. Not even this. I think it should be like this. Save. Sensor animated image. Yeah, we need to import it. So let's go import sensor animated image from source components, sensor animated image. Save. All right, so we are back to what we had before, and that's good. But the good thing is that now our image is in the sensor animated image, and we're gonna be able to use it to implement a 3D multi-layer parallax effect, which will take this tutorial to the next level. For that, what we will have to do? For that, I already prepared some assets, and you can also download them from the description below. And here in the images, we have a folder called Parallax. I have created a simple image in Canva that has a lot of elements. I can reveal it in Finder. Probably it's gonna look a bit better that way. This is the image. It has a lot of elements, and then what I did is I actually split it into multiple layers, and I left like some of these elements on different layers. And that will allow us to animate each individual layer at its own, and this will give us this cool parallax effect where it will give us the feeling that every layer is at different distance from the screen, and they will move with different speeds. So it's gonna be a very beautiful animations in the end. So we're gonna use the sensor animated image that we have created in the previous component, and this image actually works based on the sensor of the device, on the gyroscope and other sensors. As we move the screen, our image also moves there, as we roll the screen, as we tilt the screen, and so on. So this will also power our 3D parallax multi-layer animation. So what do we have to do? First of all, let's go ahead and create these components right from the beginning, and I'm gonna create a new file here. Let's call parallax.gx, and let's define it here, React Native functional export. Now this parallax, we will receive an array of images and basically an array of layers, right? Every layer that we need to render on the screen. So let's go ahead in our app.js and import parallax from components. And also we have to import every single layer for our parallax component. So from the assets, we're gonna have to import layer 1. Let me save you some time. And I'm gonna import layer 1, that is the parallax2.png, layer 2, which is the next image, and so on until we imported all 4 layers for our parallax effect. Now let's go ahead and render this parallax effect instead of our sensor animated image, and we're gonna render it like this, parallax. And as we said, we want to send all of these layers through properties to our parallax. We're gonna send it as an array, and we're gonna start by from layer 1 all the way till layer 2, layer 3, and lastly layer 4. Okay, we see on the screen the word parallax, because if we look here, that's what we're rendering here, parallax. All right, but what do we have to render there? The thing is that we don't need any view here, so we're gonna leave this empty fragment, and let's go ahead and map through all the layers. Let's map. And for every layer that we have, we are gonna render a sensor animated image. So let's go ahead and render that sensor animated image. And the sensor animated image expects a property called image. So the image will be our layer that we want to render, like this. And we need to close this tag right away. Okay. We see all the layers on top of each other. One of the problems is that we see here a warning, each child should have a unique key. So for that, let's grab the index of this layer, and I'm gonna provide a key that is created like layer underscore, and this way all our layers will have a unique key index. Now the warning is gone, but the problem is that if we look in our assets, parallax, basically image2png is the first layer that we need to see on top, basically this with React logo. But the problem is that everything is inverted and we see the last layer on the top. And this is because in app.js, that's the order we send them in, the first layer, the second, the third, and the fourth. But when we are rendering, we actually want to reverse the order to start rendering them from the last layer and all the way till the first layer, in order, to have the proper order that we expect. To reverse an array in JavaScript is very easy. We just provide here reverse to the layers before mapping, and that will switch the order of rendering these sensor animated images. And now if I'm gonna move my phone, all of this layer moves. But it's not right what we expected it to be, because we want every single layer to move with different speeds, right? Well, the layer in front should move probably the fastest, because it gives this impression that we are close to it. So basically the same as with a camera, like if we're gonna move with a camera, the objects that are close to you, on your screen, they will move very fast, and the objects far away, they will move very slowly, and this will give this depth effect. So let's go ahead and send to the sensor animated image a property here called probably layer, or not even layer, I don't know, index or distance, how far it is, I don't know, let's go with a layer, and the layer will be our index, and let's actually do index +1 in order to give layer 1, layer 2, layer 3, and so on. Let's go back in our sensor animated image, and let's receive this layer. Layer actually is a very bad name, so I don't know, let's give order. Which order is this image? Very bad still, but I'm gonna go with it because I cannot figure a better name at this moment. So having the order, what we can do is we can decide how much we are moving to the top and how much we are moving to the left, each individual layer there. So what we want to do is we're not going to touch the input range because the input range doesn't change, it's the same. What we're going to touch is the output range, basically how much we want to move. And what we're going to do, let's try to divide this by our order. I think it's image offset multiplied by 2 and then divided by order. We can try divided by order here as well for the left. And now if I'm gonna reload, let's open it up. And now as we can see, yes, all of them are moving with different speed. You can have a look at, for example, the circle and this triangle, and you can see that they all move with different speed. All right, another thing that I will do in order to improve a bit the way it looks, but this one depends on how you want this to work. The thing is that now the layer that is far away, basically the last layer in our array, it will move very slightly. It will never move all 100 pixels to the left or to the right because we are dividing this number by the order. So we are unnecessarily leaving too much offset for those layers, which is not actually what we want to do. So let's go ahead and do width plus this one divided by layer, not layer, but order. And let's do the same here, divided by order. And now our components to the bottom, they know that they don't need a lot of space to move, so they will leave only the right amount of space for them. And now when I move, like we can see that everything is so smooth and nice. They are moving on the screen, all layers with their own speed. I hope that you learned something new today, and if you enjoyed this tutorial, make sure to subscribe to the channel down below, not to miss our future tutorials and also our weekly live builds. Now you can go ahead and check out the next tutorials in this series to learn more about the gesture handlers here and about the blur views here. Bye!